Hey everyone, and welcome. So today we're going to take a journey that happens millions, maybe billions of times a second all over the world. We're going to follow a single Java program from its very first moment as just an idea all the way to becoming a fully running application. I mean, it really feels like magic, doesn't it? You write some code, you press that little run button, and poof, something just happens. But of course, it's not magic. It's actually a super fascinating step-by-step process, and by the end of this, you're going to know exactly how it all works. All right, so every single program's journey kicks off with a step that's, surprisingly simple. It all starts as an idea in a developer's head, which then gets translated into plain old text, what we call the program's source code. That's literally it. Before it's some powerful, complex application, every Java program on the planet starts its life as just text, saved in a file that ends with .java. The best way to think about this is like a recipe. It's written in a language we humans can understand, with all the instructions laid out, but the kitchen, in this case our computer, can't really do anything with it. Not yet, anyway. Okay, so this is where the real transformation starts to happen. We need to take our human-readable recipe and translate it into a language that the machine can actually work with. And this critical stage is called compilation. And the hero of this whole step? It's the compiler. It's this highly specialized program that's basically a universal translator. Its entire job, its whole purpose, is to read our .java file and convert it into a brand new format, one that's much closer to what a computer can actually execute. And here's that transformation in action. On the left, you've got your nice, clean Java code that we can all read. The compiler takes that and spits out what you see on the right. That's called bytecode. Now, it might look like total gibberish to us, but to a machine, it's a set of highly optimized instructions. This brand new bytecode gets saved in a new file, one that ends in .class. And that's pretty much the whole compilation process in a nutshell. We write the source code. The Java compiler, often called JAVEC, does its translation thing. And what comes out the other end is this portable byteclass.class file, all ready for the next part of its journey. All right, our program's been translated. It's no longer just a recipe on paper, but now it needs a kitchen, an environment where our recipe can finally be cooked up. This is where we enter the Java virtual machine, or as everyone calls it, the JVM. You know, the JVM is really the secret sauce behind Java's power. Think of it as a computer within your computer. It's this totally self-contained environment. It's the master chef who knows exactly how to read our bytecode recipe. And the absolute best part? This kitchen can be set up on Windows, on a Mac, on Linux. It doesn't matter. The chef will know how to cook that recipe perfectly every single time. So the second you hit run, the JVM just springs into action. Its very first job is something called class loading. It goes out, finds your .class file, our bytecode recipe, and very carefully loads it into its own special area of memory. And just like that, our program has officially entered the kitchen. But hold on a second. Before the chef even thinks about starting to cook, there's a super important security step. The JVM is extremely careful about what it allows to run, and it has to make absolutely sure our little program isn't going to cause any trouble. See, right after that code gets loaded, it immediately hits this verification checkpoint. And this isn't some optional thing, nope. It's a fundamental, core part of Java's design, and it was built from the ground up to protect your computer from malicious code. So deep inside the JVM, there's this component called the bytecode verifier. And you can totally think of it as this super vigilant security guard. Its job is to meticulously inspect every single instruction in our bytecode to make sure it's playing by the rules and isn't trying to do anything sneaky. So what's this guard actually looking for? Well, it's checking for all sorts of nasty stuff. It looks for illegal operations, code trying to do something forbidden. It makes sure the program can't just go and access parts of memory it doesn't own, which prevents a ton of crashes and security holes. And it checks for other technical problems like stack overflows. It's basically a safety net that's there to catch any bad code before it gets a chance to run. Okay, our code has passed the security check. It's been cleared for entry, and now it is finally showtime. The JVM gives the green light, and our program actually starts to run. This is the moment we've been building up to. Now here's where things get really clever. The JVM is incredibly smart about how it runs the code. It usually starts out using something called an interpreter, which reads and runs the bytecode one instruction at a time. But it's also watching. If it notices that a certain piece of code is getting used over and over and over again, the just-in-time or JIT compiler kicks in. The JIT swoops in, translates that busy code directly into the native machine code for your computer, which makes it run way, way faster. It's an automatic performance boost. So let's just recap. We've gone from a simple text file all the way to a fully running, secure application. Now let's zoom out for a second and talk about why this whole process was, and still is, so revolutionary. It all comes down to this one famous promise: write once, run anywhere. Because the developer isn't writing code for Windows or for Mac, they're writing it for the JVM. That means the exact same .class file can be run on any computer in the world, as long as it has a JVM. It means you write the recipe one time, and literally any kitchen, any computer can prepare it. So let's bring it all home. Why should you care about any of this? Well, it boils down to 3 huge benefits for you. First, platform independence. That program you download, it just works everywhere. Second, enhanced security. That bytecode security guard is on duty 24/7, protecting your system. And finally, optimized performance. Thanks to clever things like the JIT compiler, the JVM is always working behind the scenes to make your programs run as fast as possible. And that's the real-world impact right there. This incredibly elegant, secure, and portable life cycle is exactly why Java has been a giant in the tech world for decades, powering billions of devices. Everything from huge web servers down to the Android phone that's probably in your pocket right now. It's just an incredibly powerful and, honestly, an enduring design. This process completely flipped the script on how we build software, which kind of makes you wonder, right? If this was the revolution of the last 30 years, what's the next big one going to look like?